We have the parallel circuit. In this parallel circuit, right, we have our power supply, our energy source here, 15 volts. We have 3 resistors, 3 legs, different amount of resistance. So because each leg has a different amount of resistance, that means that the current that's coming through there is going to divide up. It's not going to be equal. Excuse me. It's going to divide up, and we'll figure out how much. Okay. So going down, solving some things right off the bat, we need to figure out what our total voltage was. And since we know that voltage in a parallel circuit is equal throughout, anywhere I take a measurement, it's going to be the same. We'll figure out our total current, making sure we use our total voltage and total resistance. Figure out our total resistance here, and then figure out what our sum of our 3 legs are equal to here as far as current goes. Okay. So let's figure out our total resistance. So first thing I'm going to do is I'm going to carry over the 1 over RT, and then I'm going to say 1 over my 470 ohms plus my 1 over 2.2 k ohms plus my 1 over 3.3 k ohms. Okay? And when I put that together, bless you by the way, I get 1 divided by 470. So if you have a graphing calculator, it usually works out a little bit better here. You can carry more numbers, get a little bit more accurate. I'm just going to carry 00213. Okay. And then if I take my 1 divided by 2200. Now, this is a good point to make right here. A lot of people don't know what this means. What does this e to the negative fourth mean? So what does that e to the negative fourth mean there? Yeah, and it represents the fact that I have to move the decimal place over still 4 places which direction? To the left, right? So it ends up being here 0.00045. We'll carry, I don't know, 455. Sorry. Yeah, 455. That sounds great. And then we get into our 1 over 3300. And again, negative fourth here, so we're going to add in here 0.123303. Okay? So I had to do it that way first because it's the whole order of operations, right? That please excuse my dear Aunt Sally. So let's add this together. 0.00213 plus 0.123455 plus 0.123303. And we get an answer of 1 over RT equals 0.00289. Are we done? What's left? We got to take the reciprocal of that answer. So 1 divided by 0.00289, enter. And we get approximately, our total resistance is equal to 346. So if you remember here, we talked about the resistance here. Our total resistance is going to be smaller than our smallest resistor. So it ends up being smaller, but it's still relatively close. It's not like it's 1 or 0.00003. If you notice that right off the bat, something's wrong. Okay? All right? So now that we have that, we can go ahead and we can figure out how much current's going through each leg. So we know that current is equal to what? Voltage divided by resistance. My voltage in all 3 of these currents calculations here is going to be 15 volts. So I can put that in right away. The item that changes, though, is the amount of resistance through each leg. So for the first one, we had 470. For the second one, we had 2200. And for the third one, we had 3300. So if we take 15 divided by 470, we get 0.0319. 15 divided by 2200, 0.0068. 15 divided by 3300, 0.0045. Okay. If I add the 3 together, that should get us what? And depending on your rounding, approximately 0.043 amps, or if we moved it over converted, we get 43 milliamps. Okay. Now, if I did my calculation up top here, and I just took my total voltage divided by the total resistance, what do you think would happen? You get roughly the same thing. So my total voltage for IT was 15 volts. My total resistance was roughly 346. So if I take 15 divided by 346, what do you know? You get roughly the same answer. Okay?